Hey, Ignite students, here we go. Minerals? Minerals are pure, minerals are uniform. We're moving on. Minerals were last time. Rocks. It's time to rock out. Here we go. Rocks are collections of minerals and other things. They're mixtures, they're not pure, they're solids at the surface of the earth. They're everywhere. Here we go. And you know what's interesting? Rocks cycle. Not the water cycle, not the carbon cycle. Those things you can see, you can feel, you experience. We live through that. Rock is rock, just rock. Rock, no move. Rock sits. How in the world is there a rock cycle? I take a big rock, I hit it, and I break it off. Now I've got a little rock and a medium rock. What? So what? Rocks cycle. And there's a long, slow path that these rocks cycle through. Here we go. All right. The rock cycle, best way to look at this is to start way down here. You've got heat. Where does the energy come from? That's an interesting question. Heat from the center of the earth. We're going to melt some of the rocks, and we have magma. This is all sorts of different minerals, all stuff going on. So you have this magma is liquid. It is so crazy to think of a temperature so hot that your rock is liquid. Okay? We're used to water being in 3 states. We have seen images, or maybe you've melted steel and metal, but rock will also melt and flow. Here we go. Magma deep in the earth is going to move around. It is not stationary. So as it moves, it's going to start to cool. And if it cools deep in the earth, we get an igneous rock. If it comes up through a volcano and now magma, lava, magma, lava, magma, lava. As soon as it leaves the volcano and hits earth, it is lava flowing down the mountain. That cools off. That is also an igneous rock. Okay? So, intrusive, extrusive. What in the world? If it's an intrusive rock, it cooled off and hardened inside. If it left the volcano and left the core of the earth, it is an extrusive rock. The lava hardens. Be careful. Intrusive, what did it intrude into? Well, this is not hollow. So when the magma moves to here, it's intruding into rocks that already exist. So that's part of the intrusive. It gets in there between those rocks and then hardens. So that's the intrusive part. The extrusive is it comes up here and then the lava hardens. All right. So those are igneous rocks, intrusive and extrusive. Weathering and erosion bring power. That is energy from the sun, creating weather, moving water, moving sediment. All of that energy comes from the sun. Energy from the sun, you weather rock over thousands of... The Grand Canyon was made by a river. Water made that. Water manipulates rock slowly, steadily, unendingly. The face of the earth has not always looked the same, right? These continents aren't exactly where they were, the shape they were. Things are always changing. 1980, Mount St. Helens, half of the mountain is gone now. You're missing a third of the mountain. It got blown away in a volcanic eruption. All sorts of stuff. Weathering and erosion are always happening. But then you transport and deposit those sediments, and as they get buried in shallow seas or near the bottoms of rivers, lakes, oceans, those become sedimentary rocks under pressure. So sedimentary rocks, we've got igneous rocks, which is cooled magma or cooled lava. You have sedimentary rocks, and then if you use internal heat and pressure inside the earth, you get a metamorphic rock. Okay? So heat and pressure change what's going on. So I would say that is the main path through the cycle. Whether it's the magma solidifies to become an igneous rock, you get weathering and erosion, and then that's turned into a sedimentary rock, which is turned to a metamorphic rock, which melts to magma. That's kind of the main path through. Here's something interesting. All three rock types, igneous, metamorphic, and sedimentary, have arrows leading to this weathering and erosion, meaning if they're formed near the surface, they can either be pushed up, the top layer can be weathered away, they can be exposed, and they themselves can be weathered. That is a direct path for all three rock types to be weathered, eroded, and turned right back into sedimentary. So sedimentary's got a loop going here. The other two can be upheaved and exposed and weathered and then turned to sedimentary. You've got other things. The igneous rock, you can have heat and pressure turn that into a metamorphic without it leaving the inside of the earth, and that can cycle. All right. Igneous rock could be reheated. That's an interesting thing. So you could have a little cycle here, back to magma, back to igneous, back to magma, over and over and over. All right. This is just one style, one thought, one way the rock cycle occurs. Let's look at this in a slightly different image here. Hey, same thing. We start with magma. You get intrusive igneous rocks that form inside the earth. You get an extrusive when it erupts and lava cools. Slow uplift to the surface, but you get weathering and erosion, transport and deposition. Now you got sedimentary rocks over here. Then heat and pressure, metamorphic rock. So your three types here are igneous. It's got it in two places. Sedimentary over here. And metamorphic. Those are your three classifications of rocks. Okay. Thoughts, comments, concerns? We now need to we're going to take today, we're going to look at igneous rocks. The next time we're going to look at metamorphic and sedimentary in the next two sessions. Okay. Starting with igneous rocks. Here we go. We need to classify these. We need to divide them up. We need to figure out ways to organize them so we know the difference between them. Because this guy that forms from cooled lava and this guy that forms from cooled magma are not going to be that similar. Okay. Here we go. This is it. This is the big fancy picture. What you have is a chart. Texture going vertically, coarse grain, fine grain, porphyritic, glassy, all of these. And then over here, you've got material, what it's made of, or you can maybe see it better on the bottom here, percent of dark material in it. All right. The number of dark minerals that are in the rock. Okay. Same kind of chart. You've got coarse grain, fine grain, glassy on vertical, and you've got composition, what it's made of over here. Let's get rid of that. Come back to here for a second. Okay. Coarse grained. All right. So coarse grained. We're not going to use that fancy word today. Coarse grained. Here's what happens. The magma slowly cools. Magma stays deep inside the earth. It cools slowly, and if it slowly cools, there are going to be very few crystals, but they're going to be very, very large crystals. Large crystals means fewer crystals, but it's because of slow cooling. That is this. As soon as this becomes lava and hits the air, it's going to cool very quickly. This may cool quickly, may cool slowly. It depends. How far did it get away from the heat source? How much did it move? What kind of rock does it end up in? Those things will determine how quickly it cools. If it cools slowly, you're going to get lots of large, or not lots, you're going to have a few large grains. So it's going to have a very coarse appearance. Okay. Fine grained, very smooth, it's going to be the opposite. Okay, it's going to cool rapidly. So there's going to be a lot of tiny, tiny, tiny little crystals. Glassy. This is lava cools. Lava cools before crystals are formed. Obsidian and pumice. Well, if it's lava, fast or slow is over here, but it's both magma cooling. Lava cooling is over here. It's left the inside of the earth. And so glassy, the lava cools before crystals are formed. So it's got more of a random appearance and structure. It looks glassy. All right. Ooh. Now, porphyritic. Okay. Porphyritic. Here we go. Porphyritic is, you have this huge pocket of magma. And it's hot, and slowly somehow it separates from its heat source below. And this giant pocket of magma cools. But it takes 10,000 years to cool. Some of the things inside there cool quickly. Some of them cool very slowly. So some of them have had time to make large crystals. Some of them haven't even barely started making crystals. Okay? So when you get this unevenness, this porphyritic rock. Okay, actually, here's what's interesting. That's the texture of the rock. We got to look at it. Here we go. So what would happen? So you got the heat coming from the middle of the earth, and you got this big magma pocket. What if maybe there's a chamber leading over to here, and this is a warm magma pocket, and there's an earthquake, there's a shift, and this gets cut off. So there's nothing flowing from here to here. This giant chunk is so big that it's going to take 10,000 years for it to cool. Some of it's going to cool quickly, some slowly. Excuse me. And so you're going to have lots of different rock types in here. It's not going to be very uniform. The minerals don't crystallize out at the same time or the same temperature. So you're going to get all sorts of different stuff. That's porphyritic. Okay. Now, composition. Here we go. Granitic, andesitic, basaltic. Granite, andesite, basalt. Okay? So granitic is granite, andesitic, andesite, basaltic, basalt. Easy enough. The granitic composition means you've got lots of light-colored silicates in there, okay? Lots of quartz, lots of feldspar, okay? There's maybe 10% dark silicates in there, which would be like a biotype mica or an amphibole. So these guys are the accessories. So what's this mean? It's the color down here. The percent of the dark mineral is telling you that down here, there's maybe 10% of the dark stuff in a granite. Now, the granite is coarse grained. But if you want if you had the exact same chemical composition and you cooled it quickly and got a bunch of fine grain, you'd have rhyolite. If you cool it slowly, you have granite. That's the difference. Okay? We're going to skip andesitic for just a second. We're going to come over here and hit basaltic. Basaltic is dark silicate minerals. Okay? So you've got the plagioclase feldspar is what this is really made of. Lots of magnesium, lots of iron going on in here. All right? So basalt is the main mineral you're going to get in a basaltic type. Why did I skip andesitic? Because it's in between, meaning if you only have 10% of the silicates are dark colored over here, and over here most of them are dark colored. Here you've got maybe more than 25% of the dark colored of the silicates are dark colored. So 25 to 45. See, right down there. Just got to read. So there's one more classification out there besides granitic, andesitic, and basaltic, based on chemically. Ultramafic. Basically, it's entirely dark silicates. This pyroxene over here, or an olivine. This stuff is very rare at the surface, the upper crust, but it's probably very common in the upper mantle. We don't have good understanding, and we can't quite confirm that, but it's probably very good chance that most of the upper mantle, there's lots of ultramafic stuff. This granitic over here, the continental crust, I meant to say that, like the crust, not the crust that's just the bottom of the ocean, but the crust that makes up the continent, that's mostly this. So small amount of the dark silicates, whether it's formed quickly or slowly, doesn't matter. Chemically, this is what lots of the crust is. We're going to look through some fun stuff here real quick. All right. So these are lava and magma. These are just the things in lava and magma. Here we go. Volcanic or plutonic. Volcanic and plutonic, those are different ways to say extrusive and intrusive. Okay, that's all it is. Igneous rock types. Here we go. Rhyolite, that's not really in this game. Granite is in the game. Diorite's in the game. Andesite's in the game. Okay? So, volcanic, this stuff erupted, right? It was cooled above Earth. That's the rhyolite. That's the andesite. The plutonic is cooled inside Earth. Granite and diorite. Here we go. The difference between granite and diorite. There's also obsidian, basalt, andesite, pumice, like the glassy that we've got. Pumice, lava stone, right? Those, when volcano erupts, a lot of the gases that are mixed in with the magma, the gases leave that, and so you get all these light air pockets, and it's very light. It floats. It's light, it's airy, it's very porous. It feels very funky. The texture's odd because there's all these things. It crystallizes very quickly. All right, let's get rid of that one. Here we go. Diorite, andesite, granite. Okay, those are all in the game. And if you play the game, you can look whatever. This is not scrolling. There we go. So granite's in the game. Diorite. Wow, computer is really killing me today. Diorite's in the game. Yep. Andesite is in the game. Those are all igneous rocks, right? Obsidian. There we go. Obsidian is an igneous rock, right? Here we go. Close that up. So obsidian is down here in the glassy because it didn't form crystals. All right. So today we learned the igneous rocks. We looked at the rock cycle. We also learned that the igneous rocks are classified based on texture over here and chemical composition, basically the percent of light and dark silicates in it. Guys, have a good day. We're wrapping up. Stay strong. Finish this semester.